The schedule, what are we going to look at today is different data types. So what kind of data do we have in the software? Then we will look at forming expressions. How can we set up expressions? What different kind of expressions are there? We will take a look at functions. Hopefully we will understand functions, or hopefully you will understand functions. And last but not least, we will look at user-defined fields and functions, what they are, how you can set them up, and how you can benefit from them. First, data types. That is, we are through that quite quickly. So what different data types are there in the software? First, we have numbers. Numbers are always written as a plain number. They may be written as an integer or a decimal value. But as said, they are always written as a plain number. No brackets or no quotation marks, no parentheses. So just plain number. We will have examples later on. A different data type is a text. And usually a text is enclosed in quotation marks, as you see in this example here. The third data type is a field. And fields usually are written in square brackets, as you see with the fields description. The fourth data type that can contain all of the above three is functions. And functions are usually written kind of as plain text with brackets surrounding the parameters. So yeah, there's a function name, then you have different parameters. But again, we will look at that in a bit. So now that you know what different data types there are in the software, we can look at expressions. Sometimes when looking at expressions, when building expressions, you may look like, or your facial expression is like the one right in the middle, because you simply think, what did I just do? But that's not what it's about today. Expression, we brought you a definition of an expression. So in computer science, an expression is a syntactic entity in a programming language that may be evaluated to determine its value. It may sound complex, complicated, but we put it in other words. So an expression is a combination of one or more constants, variables, functions, and operators that the programming language, in this case, the programming language is result 12. So we have our own programming language. It does not derive from any other program as such. There's it is similar to Excel, to Microsoft Excel. There are similarities to other programming languages, but actually result 12 is its own programming language. And the programming language interprets and computes the combination of the constants, variables, functions, and operators to produce another value. So you enter something and then you receive something else usually. In mathematics, a symbol or a group of symbols that represents an amount is seen as an expression. So a mathematical expression 1 + 2 = 3 is 1 + 2 is the mathematical expression. It's also something that you can do in the software. To make or to give a better example, we want to add sometimes the decimal time 1 plus decimal time 2. So if you have a stage race, for example, you have the finish time of your first race, you have the finish time of your second race, and your total time will be decimal time 1 plus decimal time 2. So a simple addition, subtraction, multiplication, division can be done within result 12, not only within the results section, but actually everywhere in the software. Or something like rank 3 divided by rank 3.max, which would be kind of the percentage or a value, your rank as a percentage compared to the overall number of participants. In addition to the addition, subtraction, multiplication, division, there's also an integer division. So 10 divided by 3 with the integer division equals to 3. So 10 divided by 3 would be 3.3. But here we only take the value before the comma. So here we have 3. And there's also the opposite. So we want to take the remainder after an integer division, which is 10 modulo 3 equals to 1, because 10 divided by 3 equals, as said, 3 with a remainder of 1. And where can we use that remainder after integer division? With the example in the bottom left, decimal time 4 modulo 86,400. Why do we have it like that? So 86,400 is the number of seconds within a day, within 24 hours. And if we have a multi-day race, let's assume we have a race that stretches over a week, we could have a detection on day 5, 9 a.m. And so decimal time 4, or time 4 would be 5 days, 9 hours. And now that we do the remainder after integer division with 86,400, we divide it by the full number of days, because we only want to return the time of day of that detection. So in my example, that would return 9 a.m. Now we could easily get rid of the 5 days in front of the 9 a.m. for a result list, for example. You can, of course, also do an exponentiation. So 10 to the power of 3 equals 1,000, depending on whatever you need. And last but not least, that is not as common as the other ones, I would say, is the time operator. So if you have the column 34 minutes, 23 seconds would be calculated when using the time operator. So when you simply write 34 colon 23 in a result list, for example, that would convert to 2063. Why 2063? Actually, that is simply the decimal time. So the time in seconds of the time that is written on the left of the equation. So it is 23 seconds plus 34 minutes, or 34 times 60. If you would have another value here to the left, so let's say 8 hours, 34 minutes, 23 seconds, then it would calculate 23 plus 34 times 60 plus 8 times 60 times 60. That way you would receive the value in seconds. So that's the time operator. I hope that became clear, because that may be a bit confusing. And to be honest, talking about mathematics, not in your mother language, is sometimes a bit tricky. Let's get back to something I'm more confident. Normal expressions. A normal expression can combine a fixed text, a field, or texts, fields, and functions to form a text string. So where do we use normal expressions? Actually, we use expressions quite often in a email confirmation, for example. We can use an expression in output lists. We can use an expression, for example, in a SMS that we send with instant push to participants once they cross the finish line. We can also use an expression for the wave start. And within a normal expression, individual elements are joined using an ampersand. So this in light gray, or with light gray background, is our normal expression. So here we have a text that is put into quotation marks, as we've seen when looking at the data types. Then we concatenate the text by using the ampersand, and then we add gender. As this is a field that we put it into square brackets. Ampersand, quotation marks space, because otherwise There would not be a space, a blank space between the gender and the function that will follow. So blank space put into quotation marks. And then we have a function, which is an if function here. We will look at that in more detail in a few minutes. So if the gender is M, then return male and female as a text. That's why we put it into quotation marks again. And this would be the output for a male participant. Select the gender male. But the normal expressions can be, or you can easily lose the overview and lose track of your normal expression, especially if you have longer texts. For example, in an exporter string or in an email, especially in emails. And that's where the full text expressions come into place, where you can benefit from them. A full text expression starts with a hash, and really all fields and functions within your full text expression need to be put into square brackets. When you create a new event based on any template, doesn't matter at all. Simply create a new event and then look at the email confirmation in the myresult.com section. And there you will see that we use the full text expression for the email confirmation because it's much, much easier to read compared to the normal expression. So how does that work? As that, we start with a hash, and then we simply write our text as plain text. No quotation marks, no ampersands to combine the different elements. So we have the selected gender, then we call the data field gender. That's why we put it into square brackets. The blank space here is contained within our text string. So we don't need to combine it with the ampersand. And then we call that function. And now, as we have written here, we need to put all fields and functions into square brackets. We put that function into square brackets. If we look at the normal expression again, here it is not been put into square brackets. So whenever you use the full text expression, start with a hash, put a square bracket around fields and functions. And the software will see whether it is a field or a function. So the output is exactly the same, it is identical. But yeah, with this short expression, you don't see that much of a difference, but I think you get the point. Here, it is much easier to see what will be the output. So that's all you need to know about expressions. So next point, next topic, functions. So what is a function? And the comic here tells it quite well. So we have something that goes in. So that goes in. It goes into some kind of a machine. The machine here could be a computing engine, the software, Result 12, call it whatever you want, and then you receive an output. In other words, a function takes an input to return a different output. In our example, the function is x plus 1. Now we take the input x equals 2. So the input is 2. And for the input of 2, our output of that function equals to 3. That sounds easy. But how does that work in the software? So a function is called using the function name, followed by parentheses, which contains the parameters separated by semicolons. So we have a function name. We'll look at different functions in a bit. And then we have the first parameter, semicolon, second parameter, if applicable, another semicolon, another parameter, another semicolon, another parameter, and so on and so forth. And now we want to look at the three most important, at least if you ask us, the three most important functions in the software. The first one is if. I'm pretty sure you all know an if-else statement. So we first check for a condition. If that condition is true, we want to return a value. Otherwise, we want to return a different value. So we have the condition highlighted yellow, we have a value if true highlighted green, and we have a value if false highlighted red. An easy example, if it is cold outside, so the condition is it cold outside? If true, then I wear trousers. If it is not true, in other words, if it is not cold outside, so it's warm outside, then I wear shorts. And the way we write this formula is the function name is if. So we start with if. You can also write it with a double I in the beginning. So if parentheses, and then first we start with the condition, semicolon, value if true, semicolon, value if false. With our example that we had with the expressions, that would be if the gender equals to M, the data field gender is only saved as M for male, F for female, and A for agender. So the data field gender is not male, M. Then we want to return male, and otherwise we want to return female. And here with the condition, it is important to know how to write the syntax. So here the gender is a text string field, or the value of gender is saved as a string, as a text. And that's why we need to put the quotation marks around M. With the next example, we have a number. And a number, as we've seen, as I've told you 15 minutes ago, a number is written as a plain number, no quotation marks, no square brackets, nothing. So let's first look at the switch function, and then I will continue talking about the number and why we don't need quotation marks. So the switch actually combines several ifs, with the only difference that there is no value if false. So we start with switch, and then we have our first condition. If that condition is met, if that condition is true, then we return a value. If that condition is not true, then we will check the second condition. And then we will return a different value. That could also be the same, but then you could also rephrase your condition 1. If the condition 2 is not true, if that is false, then check condition 3, and so on and so forth, as many conditions as you want. And how does that look in an event, for example? So we will use this expression or this function for the wave start, for defining different start wave or wave start times. We have 4 different waves. And first we check, is a bip smaller or equal than 100? If so, then write or return wave 1. If not, check if bip is smaller or equal to 200. If so, then return wave 2. If not, check if bip is smaller or equal to 300. If not, if yes, write wave 3. If not, check if 1 is true. 1, it sounds odd, but 1 is true. You could also write 5. So any statement that is always true. So return wave 4 for everyone else. So this kind of is the value if false. If all of the conditions before are false, then I want to write wave 4. With the example of bip, I could do it differently. I could simply say bip larger than 300, then return wave 4. But I want you to understand the logic behind it, because sometimes you have some much more complex conditions, and sometimes you simply want to return something for anyone where the conditions are not met. And there it's important that you cannot simply have the last value after the second to last value. So you always need to have a condition that is that can be true or not true. In this case, simply write 1, because 1 is always true. And now coming back to why don't we need quotation marks around a number? So a number can be larger than another number, a different number. If we would put quotation marks around the 100, then the software would think this is a text. And a text obviously can't be larger than a different text. The font size could be larger, yes, but the text itself can't be larger. You can't compare a text in a way to say, okay, this is larger than wave 1 is larger than wave 2. That does not work. And that's why we don't put any quotation marks or square brackets around the number. With a text, you can only compare, is the text identical? Is the text the same or not? So when looking at gender, you can compare gender. So just imagine the software fills that field with the value of that field. So the software can check M equals M. Okay, that is correct. So return male. F equals M. No, that is not correct. So return female. Replace bib by 5, for example. 5 is smaller or equal to 100. So yes, return wave 1. If you would put quotation marks around 100, then it would be 5 smaller than the text of 100. And that would be wrong. That condition would not be met. So that's why for numbers, always write the plain number. And apart from that, for switch, the order of the conditions is crucial, because if the first condition is met, then it will never check whether the second condition is also met. So in this example, 5 is already 105 is this first condition would not be met, but the second, yes. The third as well, but that doesn't play any role because the second condition is already met. The third function that I want you to know is the choose function. With the choose function, that is different to the if and the switch function. You have some kind of a counter, and then you have a value. So you have a choose, then you have the counter, then you have value 1, value 2, and so on. If the counter is 1, the value of the counter is 1, then it will return value 1. If the counter or the value of the counter is 3, then it will return value 3. That way you can make a life easier, because I've seen quite often that people write if contest equals 1, then return 1, otherwise check, or otherwise, or else if contest equals 2, then return value 2. If not if contest not equal to 2, then if contest equals to 3, and so on. And that way you can make it much, much easier with the choose formula, the choose function, where you simply say choose. And then, for example, contest, if someone is registered for the first contest, he will receive a black cap. When looking at triathlon, for example, someone who's registered for the second contest or contest ID 2, it will return white, and for contest ID 3, it will return blue. I hope that got clear to everyone. Otherwise, just let me know if I should elaborate further on it. But these were only 3 functions, and these are the 3 control functions. But there's much, much more functions. We have string functions, we have mathematical functions, we have result functions, we have conversion functions, we have time and date functions, check functions, inter-record functions, other functions, and scoring functions. And because we don't have so much time, I told you that we will hopefully stick to 45 minutes. I will simply tell you where to find all of the functions. So when you go to the knowledge base and search for functions, or navigate to result 12, fields, expressions, and functions, and then go to functions, then you have the list. And then you have the same overview that you've just seen in my presentation. And what are string functions? Okay, left, right, mid. I'll have an example on that in a bit as well. So you see there's quite a few different functions, mathematical functions. You can take the square root, for example, have an absolute number. So actually the integer or integer here are absolute. So you don't have negative values, and so on and so forth. But to give you at least a few examples of different functions, one text function is left, for example. And left x, y returns the left y characters of a text string x. So if you write left, Elliot, semicolon 3, it will return the left 3 characters of that text string. So in this case, ELL. Of course, you can call a data field here as well. And then don't put it into quotation marks, but put it into square brackets. Another example is the speed function. The speed function returns the speed of the time x according to distance y of units z. So in this, with this expression, with this function, we want to get the speed of the decimal time 10. Here it is always important to write or to call the decimal number or the decimal time. You could also simply write T10. So we want to calculate the speed of that time value on the distance of 5,000 meters. When you use splits, as we've discussed last time, the speed and also the pace, they are calculated automatically, but this applies to the advanced results, for example. Another function is tcount. Tcount xy returns the number of results which have a time between result IDs x and y. So tcount1 semicolon 10 will check how many events, how many results, or how many times you have in the results 1 through 10. Sometimes you have sometimes you want to count the number of results or the number of times in your results 1, 15, 28, and 43. Then you can use tcount. I won't go into much further detail, but when you search for tcount, for example, you will find it. And there's also the description for it. The last example of a function that I have prepared for you is the format function. And you won't believe, but the format function is amongst the 3 top searched words in the knowledge base. And the format function, with a format function, you can format a decimal time x as a text string with format y. So format 1234.5 in the text format of hours, minutes, and seconds, but hours only if they are not leading hours, or so only if this is not a leading 0, would return 2034. Because we don't want to show decimal times, and I base this on rounding down to a second. If I would want to show decimals, I would need to write .k, for example, for 1 decimal value. So now that we looked at expressions, data types first, and expressions and functions, then there's only one thing missing now, which is the user-defined fields and functions. And what are they? User-defined fields and functions allow for quick reference to commonly used expressions. And in every event file, you have some default user-defined fields and functions, like display name, for example, gender MF, which capitalizes the gender. You have male, female, which translates the M, F, or A into female, male, or agender. But you can also create custom functions for converting a variety of fields. So you won't believe, but every so often people need another function. And you can build your own function. So here with status X actually is a function. And whenever you call with status, and then you enter a value or call a field, then this will actually call this function, which is a choose status plus 1, because the regular status is 0. And then you want to have the first, actually here we have it again. So you would call with status time. Time is the finish time, or the time that you mark as the finish time in your contest settings. So when you write this expression or this function with status time, then for every participant, it will check which status does the participant have and adds 1. So for everyone who has a regular status, this will be 1. This mathematical expression will be 1. So it will take the first value, which is X. So this will be replaced by what you enter in your function name. So with status time, for a regular participant, will return the time. For someone who has a status of 1, this expression would be 2. It would show a.k. Or status 2 would show disqualified. Status 3 did not finish, did not start, and so on. Actually, let's have a quick look at the software. Here at the user-defined fields, you will find them on the main window, participants data, user-defined fields. I will zoom in a bit further, so that's easier for you to see and read. Another quite helpful function is the yes/no function. For those of you that use the software for more than 2 or 3 years, you will probably not have the yes/no function by default, because it has been added not recently, but a few years ago only. And this will easily convert a checkbox field into yes or no instead of 1 or 0, as it is usually coded. And here again, you see X is the placeholder. And whenever you write something into parentheses in your user-defined field or function name, you also need to have that placeholder in your expression. So you could also write yes, no, placeholder, but then you also need to have the exact same name in the expression. So you could also write if placeholder. It may make sense that you describe your placeholder here in your function name, because when you call that field, or when you use the field wizard, because you may have like a ton of user-defined fields and functions, you don't know exactly in which order you need to write your different placeholders, then they will be shown here. And that way it may make it easier for you to remember what you can do with a certain function. Of course, here it is. It doesn't really make sense if you only have one, and yes, no, this is quite obvious. But you could also create a new function, which let's simply call it test x, y, z. So you can have more than one parameter that needs to be defined. And then you could say if x larger 0, so assuming x would return a number, then write y, and otherwise write z. That could work. I don't have a fitting example for that, but that would work. And now, how should you know what is x, what is y, what is z? So here you could also write time if true, if false, and now you also need to adapt it in your expression. And now let's save and don't click import, but refresh. And now if I would need to call that function, I would easily see, okay, the first parameter that I need to enter is the time. So I would say, okay, finish time. Second was if true. So when the finish time is is larger than 0, actually it need to be time.decimal. Then return the time and otherwise return the status. That could be a valid function in an output list. Of course, that doesn't make sense in a user-defined field, but that would make sense in the output list. Just to give you an example, how you can build your own functions. And one more thing I want to add here is the code editor. Let's take this one, yeah. With the code editor, this allows you to have a better overview of the expression. So everyone who deals with coding in general might be aware of that, but yeah, this is quite easy. Whenever you have a semicolon, it will add a line break, because that way you can more easily keep track of your functions. So we have a switch function, then we have an opening parentheses, which will add a line break and which will let the next line start more to the right. So the first condition would be club unequals empty, then write club. Then the next parameter is city unequals empty, and write this. And then you have the closing parentheses. So the code editor pops up whenever you have your field here. Usually you have the field wizard, but as soon as you have an opening parentheses, for example, or any parentheses or square bracket, then you can call or open the code editor. This really can be helpful. So this can really be helpful if you have long formulas, long functions, and then it can be difficult to really read all that in the same line. Okay, so what are possible applications of the user-defined fields and functions? And we are also on, soon about to finish soon with this. So possible applications, a wave definition. We will look at one possible wave definition on the next slide. You can also use the user-defined field for defining the race category or the race division, the position on course, for example, a video or photo URL, which you then can send in an email after the race. There's also a guide how to link a video or photo to your results in the knowledge base. You can use the user-defined fields, for example, for stage race results or ranks. Of course, you can also use the advanced results for it, but sometimes the user-defined fields make more sense. You can use it for time formatting. There's also an example at the very end. You can also use it for error checking. So actually, there's no limits on what to use the user-defined fields and functions for. So as promised, one example for a wave definition. So we want to set T0, the start time, according to an expression. And here we use a switch expression. So we say switch is wave override empty or not empty, then write wave override. Otherwise, check if is elite, the checkbox field, is it set or not? If yes, write elite. Otherwise, check if contest is larger than 0 and then write age group 1. So this is kind of the decision tree. If wave override unequals empty is yes. So if it is not empty, write wave override. Otherwise, check if it is elite. If yes, write elite. If not, check for contest. If contest larger 0, then write age group R1. And if not, then the expression or the function will be empty. It will return nothing. And this wave definition can be helpful. So it derives, as far as I know, from a triathlon event where you have different start times per age group. But in that event, the previous year, an elite athlete, the elite athletes, they start at the beginning of the race, no matter what age group they are. But one elite athlete, not sure if he lost his chip, if he forgot his chip, but for any reason he wasn't disqualified, but he was allowed to start later. So he was allowed to start together with the age group starters. But it would become quite difficult to set him his own T0. So for this participant, the wave override, which is an additional field, would be set to the name of the age group he started together with. And that way, he still got his individual T0, even though he was elite, because wave override was no longer empty. So it took that first value before even checking if it was an elite athlete or not. And now the last slide, last example, a custom time format. We talked about that already in the beginning. When you have multi-day events, you often don't want to know whether it was the time comes from the first day, second day, third day, fourth day, whatever. So you could create your own function called as TODX. And as TODX would actually be the expression or used expression format X. So format this field in this format. And I told you as well that you can use the remainder division, but you can also use that as your format in the format function. So you would get rid of the number of days and it would simply return the detection as time of day. And then you could, for example, use it as time of day lab n or as time of day last seen .decimal. So it's only important that you use the decimal value for the field that you call. And that was it for today. That was it about expressions and functions and user-defined fields and functions. I don't see any questions. I hope that is a good sign. I hope that you all got what I was talking about. If not, now it's your time to ask a question. If I was too fast, of course, you can always re-watch this session later on. Probably the end of tomorrow or Friday, we will usually have it available in the knowledge base. Of course, you can also read the knowledge base itself, where we have all that described in text form. Okay, I'm glad we got one question at least. So what does AK stand for? Actually, this is the with status. By default, I think calls the German status descriptions, and A.K stands for something like out of competition. So he's allowed to take part, but he, for whatever reason, doesn't get a scoring, for example. Thanks for watching. Thanks for tuning in. You will see me soon. Thanks and bye-bye.